Hi everybody. Thought I'd give you a brief recap of what happened in the last class here. We created in ImageUtils a program, well, a little static method that would allow us to invoke the median cut algorithm from anywhere in our system. We pass in an image, we pass in the number of colors we want, and what comes out is another image that's been requantized. Following the book, we make a new instance of a short image bean, use that to get the pixels in a one-dimensional array, tell the median cut algorithm how many pixels there are in total for width and height, do a convert, and return. Once we've got that done, we proceed with the creation of a processor using the annotation techniques discussed in class. There's also a paper available. The basic idea is that you provide semantics. The semantics come in with an annotation that tells us what the guidance should be for the construction of a GUI. So here's the height of the image, and it looks like, well, this is the height of the grid. It can range between 1 and 100 with an initial value of 2, and its name is height, and we go in increments of 1 cell at a time. Similarly, for the width of the grid, we can subdivide the image into 100 different parts. When we want to set a color, that'll be the color of the grid, and we'll get a GUI that automatically creates on that. For the number of colors in the image, we can set the number of colors. The initial value will be 16, and it ranges from 1 to 256, and the GUI will display number of colors in the image. This acts like a plugin. So the Adaptive Median Cut processor, which implements the image processor interface, has to provide a mechanism for processing the image, which means there's an image that comes in, an image that goes out, and these parameters will change the behavior of the algorithm. So here's the process that actually gets invoked by the GUI that's automatically constructed. We get a buffered image because our intention is to draw the grid directly on the image, but also we want to be able to do some processing on each element inside of that image. So when we cut using median cut, not only do we draw the rectangle, but we also draw an image that's been requantized. The median cut window uses the buffered image, grabs a sub-image out of the buffered image, does the median cut on the sub-image, draws the sub-image using the graphics context on the master, and then proceeds to display that on the that quantized image on the buffered image. So what happens? Well, we go out to the color menu. We make a new instance of a run annotation menu, which creates the GUI for us, throw the adaptive median cut processor in, pass in the main method so that we can get updates, and then we proceed to run. The interesting thing I think about this approach is that you can make up as many plugins as you like. These processors are just operators, and the operators allow us to automatically obtain operators. So if we go in and we look at our adaptive median cut processor, we can see the graphic user interface has been automatically constructed. If we do an update, we can see the new grid. We can adjust the number of colors, and we can see the number of colors is changing differently in each region. Then what we can do is we can change the total number of regions in width and in height. Moreover, we can open up a different image. And we can have that effect as well. And that's what you'd expect to see for your homework when things are working properly. Pretty slick, right? Adaptive median cut algorithm. Thank you very much for your attention.